Earth's Material and Processes, Chapter 3, Section 3, Mineral Resources. My name's Mr. Ruby, and I'm joined here by Jacob Estes. Say hello, Jacob.
Hi, everybody.
And Jacob and I are going to read for you the Mineral Resources, Section 3, and then put it on the Google Classroom and a link on MrRubyScience.org. I'll start us out, Jacob, if that's all right.
Okay.
Metallic mineral resources. If your room at home is anything like the one shown in Figure 18, you will find many metal items. Metals are obtained from Earth's materials called metallic mineral resources. A mineral resource is a deposit of useful minerals. See how many metals you can find. Is there anything in your room that contains iron? What about the metal in the frame of your bed? It is made of iron. Is it made of iron? If so, the iron might have come from a mineral, from the mineral hematite. What about the framing around the windows in your room? Is it aluminum? Aluminum, like that in a soft drink can, comes from a mixture of minerals known as bauxite. Many minerals contain these and other useful elements. Which minerals are mined as sources of materials you use every day? Why don't you read about ores for us, Jacob?
Okay. Ores, deposits in which a mineral or minerals exist in large enough amounts to be mined at a profit are called ores. Generally, the term ore is used for metallic deposits, but this is not always the case. The hematite that was mentioned earlier is an iron ore, and the bauxite that was mentioned earlier is an aluminum ore. And aluminum are metallic ores.
Thank you.
Yay.
So here in Figure 18, it shows a bedroom, a very neat bedroom, with an old-timey boombox, some aluminum cans, and a metal spoon, showing all the different materials that can be used for that. Economic effects. When a mineral is deposited, when a mineral deposit is considered ore. When is a mineral deposit considered ore? My goodness, we're both having a hard time reading today.
Yep.
When a mineral deposit is considered, when is a mineral deposit considered an ore? The mineral in question must be in demand. Enough of it must be present in the deposit to make it worth removing. Some mining operations are profitable only if large amounts of mineral is needed. It also must be fairly easy to separate the mineral from the material in which it is found. If any one of these conditions isn't met, the deposit might not be considered an ore. Supply and demand is an important part of life. You might have noticed that when the supply of fresh fruit is down, the price you pay for it at the store goes up. Economic factors largely determine what an ore is. So they're saying if it's worth money, then it's an ore. If it's useless, then it's just a rock. All right, refining ore. Why don't you give it that a try?
The process of extracting a useful substance from an ore involves two operations: concentrating and refining. After a metallic ore is mined from the Earth's crust, it is crushed and the waste rock is removed. The waste rock that must be removed before a mineral can be used is called gangue.
Yeah, it's gangue.
Okay.
Yeah, gangue. Refining produces a pure or nearly pure substance from ore. For example, iron can be concentrated from ore of hematite, which is composed of iron oxide. The concentrated ore is then refined to be as close to pure as possible. One method of refining is smelting, illustrated in Figure 19. Look at the smelting, Jacob. That looks very warm.
Yeah, it's pretty cool.
Yeah. I wish we could smelt right here in class. That'd be
Probably
delightful and hugely dangerous.
Yeah. Sounds fun.
Yeah. One method of refining is smelting, illustrated in Figure 19. Smelting is a chemical process that removes unwanted elements from the metal that is being processed. During one smelting process, a concentrated ore of iron is heated with a specific chemical. The chemical combines with oxygen in the iron ore, resulting in pure iron. Note that one resource, fossil fuels, is burned to produce the heat that is needed to obtain the finished product of another resource, in this case iron. Non-metallic mineral resources. Why don't you take over on this?
Okay. Any mineral resources not used as fuels or as sources of metals are non-metallic mineral resources. These resources are mined for non-metallic elements contained in them and for the specific physical and chemical properties they have. Generally, non-metallic mineral resources can be divided into two different groups: industrial minerals and building minerals. Some materials, such as limestone, belong to both groups of non-metallic mineral resources, and others are specific to one group or another.
Thank you. And we're getting towards the end of this. Industrial minerals. Many useful chemicals are obtained from industrial minerals. Sandstone is a source of silica, which is a compound used to make glass. Some industrial minerals are processed to make fertilizers for farms and gardens. For example, sylvite, a mineral that forms when seawater evaporates, is used to make potassium fertilizer. Many people enjoy a little sprinkle of salt on French fries and pretzels. Table salt is a product derived from halite, a non-metallic mineral resource. Halite also is used to help melt ice on roads and sidewalks during the winter to help soften water. Other industrial minerals are useful because of their characteristic physical properties. For example, abrasives are made from deposits of corrodium and garnet. Both these minerals are hard and able to scratch most other materials they come into contact with. Small particles of garnet can be glued onto a sheet of heavy paper to make abrasive sandpaper. Have you ever used sandpaper before?
Yeah, in Indotech.
Excellent. Figure 20 illustrates just a few ways in which non-metallic mineral resources can help make your life more convenient. Figure 20. Road salts, chemicals, and glass. We all enjoy glass. Building materials. You want to give the first paragraph a try?
One of the most important non-metallic mineral resources is aggregate.
Aggregate, yep.
Aggregate is composed of crushed stone or a mixture of gravel and sand and has many uses in the building industry. For example, aggregates can be mixed with cement and water to form concrete. Quality concrete is vital to the building industry. Limestone also has industrial uses. It is used as paving stone and as part of concrete mixtures. Have you ever seen the crushed rock in a walking path or a driveway? The individual pieces might be crushed limestone. Gypsum, a mineral that forms when seawater evaporates, is soft and lightweight, and it is used in the production of plaster and wallboard. If you handle a piece of broken plaster or wallboard, note its appearance, which is similar to the mineral gypsum. Rock also is used as a building stone. You might know of buildings in your region that are made from granite, limestone, or sandstone. These rocks and others are quarried and cut into blocks and sheets. The pieces then can be used to construct buildings. Some of the rock also is used to sculpt statues and other pieces of art.
Excellent. Then there's a problem-solving activity, and then we get into recycling, mineral resources. Mineral resources are non-renewable. You've learned that non-renewable resources are those that Earth's process cannot replace within an average human's lifetime. Most mineral resources take millions of years to form. Have you ever thrown away an empty soft can? Have you? I haven't. I'm too cheap. I like my 5 cents. Many people do. These cans become solid waste. Wouldn't it be better if these cans and other items made from mineral resources were recycled into new items? Of course it would. Recycling is using old materials to make new ones. Recycling has many advantages. It reduces demand for new mineral resources. The recycling process often uses less energy than it takes to obtain new materials. Because supplies of some minerals might become limited in the future, recycling could be required to meet the needs of certain materials as shown in figure 21, which shows a whole bunch of things: chromium, nickel, platinum, magnesium, tin, silver, and copper. You want to finish it up for me? Right here at recycling.
Recycling is using old materials to make new ones. Recycling has many advantages. It reduces the demand for new mineral resources. The recycling process often uses less energy than it takes to obtain new material. Because supplies of some minerals might become limited in the future, recycling could be required to meet needs for certain materials, as shown in Figure 21. Recycling also can be a profitable experience. Some companies purchase scrap metal and empty soft drinks cans for the aluminum and tin content. The seller receives a small amount of money for turning in the material. Schools and other groups earn money by recycling soft drink cans.
Thank you very much, Jacob. The end. Enjoy this screencast.